So guys, yesterday we talked about integral functions. An integral function is this. It's a function that is an integral. And usually the x variable, the input value, is somewhere on the limits there. We talked about the second fundamental theorem of calculus, that if you have an integral function, the derivative of that integral function is basically just the integrand. Okay? And then we did a couple of exercises with the second fundamental theorem of calculus. We talked about how to find relative extrema. Where is the integral function increasing? Where is it decreasing? And you could tell by looking at the graph of its integrand over there. We also found where the integral function would have concavity and points of inflection by looking at the graph of its integrand over there. And so that's where we're going to be picking up today. So yesterday we found relative mins and relative maxes. What we're going to start off with today is finding absolute mins and maxes. So we're going to be using, so that's what the candidates test is for, okay? Candidates test is the way you find absolute minimum and absolute maximum. So just to kind of review really quick, where is the relative extrema for G? Not F. This is a graph of F, okay? I'm not asking where's the relative extrema for F. I'm asking where is the relative extrema for G on this function? At the x-intercept, so at -2. And maybe Brandon, can you tell me if that's a min or a max for G at that point?
That's a minimum.
It is a minimum. Very good. So the x-intercepts are where the integral function will have its mins or maxes. And since we're going from a negative to a positive at that point, then the integral function has a minimum at that point. So that's some of the stuff that we talked about yesterday. That's how you find relative extrema. But to find absolute extrema, a little bit of a different ballgame. We're going to have to use the candidates test.
We were in like a VR thing.
You can just leave them on the desk, guys. That's cool. Thank you. Who was it? That was Al, Melissa, and who else? Help me out there, Brandon. Okay. So how do you do this? Well, candidates test, it's called the candidates test because you're basically finding candidates for the absolute extrema. Which of these candidates are the absolute max and which of these candidates are the absolute min? So your candidates are the endpoints, and they're also the critical values, however many there may be. Yep, that's it. So critical values are where the derivative is 0 or undefined. So you have to find where the derivative is 0 or undefined to find where the critical values are. Endpoints are usually just given to you. So let's continue here. So that's where we're going to start off. We're going to start off with example 4, finding the absolute extrema of this integral function here. So now this is important. I want to emphasize this again. I had a few people doing this last block. I said, what are the, and this should be labeled, by the way. So let's label that f of x. I asked, what are the absolute extrema? And people are like, oh, well, it's -2. It's right there at the lowest point on the graph. But we're not looking for the absolute extrema of f. We're looking for the absolute extrema of g. Okay? And g is the integral of f. So that's a different story, right? So we're going to follow our mathematical steps that we're aware of. Okay? So we're going to have to do the candidates test. Now with the candidates test, I'm not going to put y there. I'm going to put g of x just so we're clear about what we're talking about. With the candidates test, we want to include the endpoints. What are my endpoint x values there? I handed them out yesterday. Were you gone yesterday?
Oh.
Yeah, same handout from yesterday. All right. Now we want to find our critical values, okay? So how do you find critical values? That's where the derivative, which is what? F of x equals what? 0 or undefined. The undefined doesn't really apply here. So where does that graph over there, f of x equals 0? Yep, that's the relative extrema, right? The relative extrema are your candidates. They're your critical values. So we have -4 and we have 2. Those are my things. So basically what goes in your candidates test is the endpoints and the places where that integrand function over there touches the x-axis. Okay, so now we need to find out what the y values are for each one of these. And that's where a lot of work is going to come into play. We have to plug in a number here for each one of these. So let's go ahead. I'm going to start with g of 8. Okay, I'm going to do g of 8. How do we find g of 8? Well, we're going to come back up here to our original integral function here, and I'm going to replace the x on the top with 8. That's the first thing we do. Now, I need to figure out what this is. Well, that's just asking me to find the area under the curve from 0 to 8. So let's do that. We want to go from 0 to 8. So here's that area. Let's break it up into the pieces that we like. So if I want to add together all these areas, these are just going to cancel, aren't they? And what's that last piece over there? So that's how you do it. You got to do your area to evaluate the integral function. So this one is 8. We have to do the other ones there. So I'm going to let you guys do g of 2 real quick. Go ahead and find g of 2. If you want to look at your notes, the very first slide that we started filling in, it's the same function. What I think we got g of 6 was -6 was 3, right? Where was I? 3. And how about g of -4? What do we get for that? 4. Okay, so you just kind of basically keep finding the areas, right, that you need. And then from there you can identify your max. So my absolute max and my absolute min. Let's identify those. What is my absolute max value? 8. And what's the absolute min? There you go. So my absolute max happened at an endpoint, and my absolute min happened at one of the relative extrema. So, all right. So that's that. Go ahead and once you guys try some there, try to find the absolute min and max for that function real quick. I'll give you a little bit. So let's begin here. Chris, what was your absolute min? -12? Ryan, what was your absolute max? Huh? Okay, we'll get there, but what's your absolute max?
I got 12.
12. Okay, so I think this one is wrong. So let's go ahead and see what we can do about it. So first of all, g of -6. We're going from 4 to -6, right? Now I'm not going to take time to calculate all of these just because of time. But first of all, we would have to flip this one. Okay? And then second of all, we need to find the area. So what is the area from -6 to 4? So from -6 all the way up to 4. So here and then here. Now, I bet a lot of you guys were breaking this big triangle up into pieces, right? There's no point in that. You totally save yourself time just trying to find the area of that big giant triangle. So 4 to 4 is 8 times 3 is 24. Cut in half is 12, but it's negative because it's under the curve. And then this little guy up here is 1. Now, if we're adding those together, we get -11, right? And since there's a double negative, it comes out positive. So that's how you do that one. Now, I'm not going to do the rest of them, but if you had done the rest correctly, you would end up with 12 0, and 3. And so we could see that our absolute max is 12, but our min is actually 0. Okay? So, let's go ahead and proceed on to another type of question. All right. Now, guys, pay attention. This was a little confusing. It's weird. It's totally unintuitive. But we're going to pull together. It's a weird way to solve a problem, but it's a really cool one. It's actually a very popular AP question. It's on a ton of the FRQs. So I want to make sure you guys know how to do it. So here's the deal. What do you notice is missing in the directions up here that all the other ones have had? So, there you go. So we're missing the integral function. We're missing the integral function, but this is a secret integral function. They're just not writing it that way. So I'm going to show you why it is an integral function, but we have to create that ourselves. That's exactly it. There you go. So, Nate and Manny, I'm going to ask you not to talk right now. So, here's why this is an integral function. Because this is a graph of what? F prime. But what are they asking us about? They're asking about f. How do you get from f prime to f? You integrate. So this is an integral question, right? And therefore, what we're going to do is we're going to create an integral function ourselves. So everybody go ahead and put integral in f prime. And I think most of you guys are going to be okay with that, right? Now, here's where you're going to start feeling a little bit uncomfortable, but I'm going to help you guys out with this a little bit. Ready? We need to put a number here and a number here. It's not letting me draw it, but there we go. All right, so now this is the part that makes people feel weird because it's not exactly obvious, but here it is. So those are x values, okay? So how do you know what x values go there? Well, you're going to put the x value for the one that is given, and you're also going to put in the x value for the one that you're trying to find. Now, it's kind of vague language. But what x value do I know the answer for? So we're going to use that. And what x value am I trying to find the answer for? 2. So we're going to use -4 and 2. Which one goes on the bottom? Yep. So there's that. You guys good? So first thing we're going to recognize is, since I'm going from a derivative to the original, it's really an integral. Okay? The next thing that we're going to notice is how do you get the limits? You take the x value that's given, the x value you're trying to find the y value for, you put them in, make sure you put the smaller one on the bottom. Cool? Now this is another part that's not at all obvious, but here we go. We're going to do the fundamental theorem of calculus. According to the fundamental theorem of calculus, what does this equal? Good. F of 2. There you go. That's, if you guys can get that far, then you've gotten through the hard part. It's setting it up. Okay? So let's back up one more time. So step 1, recognize they give you a derivative, but they're asking us about f. That means we're doing an integral. Step 2, get your limits straight. Your limits are the x value you want and the x value you have. Step 3, apply the fundamental theorem of calculus to find the right side of your equation. Once you get that far, we're just going to do stuff that we already know how to do. Okay, so for instance, can we calculate what this actually equals? How would I do that? It's an area under the curve. So let's do that. We're going to go from -4 to 2, which is how much? 6 times 2. You're right. It is. It's -6, right? Okay. So -6. I agree. So I'll put area. So the area under the curve is -6, right? But let's bring down the rest. I'm looking for f of 2, right? Isn't that what I'm trying to find? But I know what this equals. What does f of -4 equal? Can I solve for f of 2? Kind of weird, but yeah, we can. You're just going to add 5 on both sides, and you got your answer. Kind of weird, right? So we're going to do a guided practice and then a student practice to make sure you guys have got the steps down. So it's kind of an awkward type of problem, but Basically, you have your setup, plug in what you know, solve, right? Okay. Guided practice time. All right, so find your guided practice. Here we go. Ashley, this says this is a graph of f prime, but I'm being asked to find something about f. What does that tell me? Yep, we're going to be integrating our derivative, right? Okay, the next question is going to be going to Sam Jones. Sam, what numbers am I going to put here and here? Good. Which one goes in the bottom, Sam? Huh? -4. Good. Okay, I have to put it there. It's kind of not writing. All right, Serena, what goes on this side over here? Mm-hmm. Good. Thank you. And next question is going to go to Dario. Dario, I need to find this. How do I do that? Good. So we're going from -4 to 4. Why don't you guys go ahead and do that real quick? I'll call on you in a second. Oh, you already know it? No. Yeah, because we're going from -4 to +4. Yes. -4. You guys good with that? Okay, take your time. I'll let you guys have some thinking time. -4? Okay. Let me back up a little bit. Let's talk to Max. Can you tell me what you write on the right side of this equation, please? Now, you guys, there's a little bit of a difference here. Not much of one, but a little bit of one. Notice how this time the number that we know is here instead of there. And you'll see that makes a little something happen here. So first of all, minus the 3. And so we get this. Here's the little something that happens. I saw a few people doing this last block. That negative is still there. Don't get rid of the negative in front of the f because you're going to have to divide it out. Okay? So anytime one you're trying to find is the second number with a negative in front of it, you're going to have to divide by a negative. But there's your answer. So f of -4 would be 7. Okay? So that was a guided practice, and the reason why I'm doing this is because it's a weird problem, it's a new approach, and it's a really important type of question. So I want to give you guys one more to do completely on your own from beginning to end. Probably won't put it up on the board, but just give you guys a chance to get it, and we'll shout the answer out in a second. So take like a couple minutes to see if you can knock it out. All right, so answer should have been 12. Integral -6 to 0. Uh-oh. Okay, so you find your area, you plug in what they give you for 9 and solve for f of 6, and you should end up with 12. Okay, so let's go ahead and move on to our last question for the day. So our last question, it's weird because we've already done it, but it's really just putting example 4 and example 5 together. So let's talk about this. In example 5, what are we doing? I'm giving you a derivative function and asking you to find a y value, right? That's what example 5 is. What's example 4 all about? Close. What was example 4 all about? Candidates test. Absolute extrema. Absolute extrema. Now, do you have to find the y values when you're doing absolute extrema? Yes, you do. So we're going to use this strategy to find the y values. So it's going to be the candidates test again, but instead of me giving you the integral function, it's going to be written as a derivative instead, and we're going to have to set up our own integral basically to get the answers. So it's basically like combining example 4 and 5 together, but let's do it, and this will be the end of our lesson for the day. So, all right. Yay, quarter circles. You love them. Say it. All right. Whoa.
Fractions.
What?
Fractions are good. Circles, garbage.
Whoa, bro. All right. The graph of f prime of x is given below. So this is the graph of f prime. But they're asking us about f, right? They're asking us to find y values, which is an f value. So we're talking integrals again, right? So let's go ahead and do our candidates test. X, and this is a good question. I'm going to use my cards. Jennifer Castillo.
Oh, man.
What goes right here? F of x. Why is it f of x?
Because that's the function you're trying to find.
Close. What are we trying to find?
The absolute min and max.
Good. And what are those?
The y value.
So y values, right? So if you put your derivative here, what are you finding? You're finding the slopes, right? But if you do f of x, you're finding the y values, right? All right.
Wait, I got it right?
Yeah, good job. Sorry, I forgot to end that with good job. You did it. I'm sorry. All right, so I think David's gone. No longer with us. Maya's gone. She's no longer with us.
What? So sad. Nate, it would be great
If you could tell me what numbers go in the left-handed column here.
-4.
Yes.
0.
Yes.
2 and
Breaking my heart. No 2.
0.
You're good so far. -4 and 0 I like.
Okay. 4
Yes.
and 6.
Good.
Let's go.
So it's the endpoints, right? Now let's talk about why that is, right? Because I want to find critical values. Critical values happen, well, let me use my card. Critical values happen where what happens? Not Ricardo, he's gone too. Austin, critical values happen where what?
The slope is 0 or undefined.
Where the slope is 0 or undefined. This is a graph of the slope. So where is this graph 0? At 0, 0, where else? Good. So that's our critical values. And where are the endpoints? Well, that's these. So we only need those ones. We don't need that 2 down there. That's not a critical value. It's not an endpoint. It's not a relative extrema. Okay? All right. So let's go ahead and continue. This is where we get to have some fun. I need to find out what f of -4 is. I also need to figure out what f of 0 is. And I also need to figure out what f of 4 is and f of 6, because that way I can find, once I get those, I know what the absolute mins and maxes are. So now this is where, huh? We do? Which one do we have? Okay, good. Thank you. What is it?
3.
Beautiful. They have to give you one. If they don't give you one, you can't do the problem. Well, actually you could, but it's confusing, so I'm just gonna say no. But it's not usually they give you one. So there's that, right? Now, gosh, how am I gonna find that? This is where things get interesting. You ready? You already know? What am I gonna do? The answer is 0? Why? The integral, you mean? Well, I don't have an integral yet, so maybe you're right. But I'm not convinced yet because I need to see my integral. So let me see here. So I'm trying to find an f value, right, you guys? But I only have a graph of f prime. How can you find a value of f if you have an f prime graph?
Take the integral of from -4 to 0.
Okay, good. So first you're right, but I want to back up a little bit. So we're going to integrate. If you have f prime, but you're asking things about f, you need to integrate it. Okay, now which one am I trying to find? I'm trying to find 0. I'm trying to find what f of 0 is. But that's not enough. I need 2 x values. What other x value should I use?
6.
-4. Why would I use -4? Because I know that one. I know that at -4, I have 3, right? So remember, same rules last time. The one you want and the one that you have already need to be the ones you choose. So we're going to use 0 and negative 4. So which one should go on the bottom? And up here? And over here? Right? Okay. Now what's this? It's 4?
Attention students and staff, false alarm, do not evacuate.
I agree.
False alarm.
4. So we're doing the area from 4 to 0. And that little triangle has an area of 4. Yes. And over here, I'm looking for f of 0, but I have f of negative 4. It's 3, right? So what's my answer going to be? 7. Okay. Let's do another one. Can I erase? Now I want to find f of 4. So, f of 4. So let's see if we can set it up. Go ahead and see if you can set up an integral to find f of 4. No, nothing for the final answer, just the setup. So, what do you think, Jade? Can you help me out? So I want to find f of 4. So what's it going to be? Good. Okay. So let's do that. Negative 4 to 4. Wow. Okay, so that's, we already know this one was how much? 4? Okay. Now over here we have a little triangle here. This is negative 1? No, negative 2. This guy. So it's pi r squared, right? Over 4, because it's a quarter circle. What's my r? Those cancel. It's pi and it's negative because it's underneath, right? Okay. So, yeah, 2 minus pi altogether. So if you add up all 3 of those, you get 2 minus pi, right, guys? And that's what is equal to f of 4 minus f of negative 4. Which one do I know? Negative 4, right? So minus 3. Add the 3 over. What's my answer going to be? 5 minus pi. 5 minus pi. And pi is about 3, right? So 5 take away 3 is going to be pretty close to 2. So when we're trying to figure out what the min and max is, just know that number there is pretty close to 2. Which means that number there is not going to be a min or a max because we already have, well, it could be a minimum, but it's not a max because we already have numbers bigger than that, right? Let's go ahead and do f of 6. See if you guys can find f of 6 real quick. Because so this is the area under the curve from negative 4 to 4, right? So I just added together all these little areas, and I got 2 minus pi.
Oh, so we're not using 0?
0?
Yeah, I thought, no?
Um,
That's why I was
a little bit, yeah, because what these are the f values of the function, and you get the f values of the function by adding areas up, but it's not necessarily just the area. So for instance, f of 0 is 7, right? But if you integrate from negative 4 to 0, that's not 7, it's 4. So why is it 7? Because at negative 4, our problem starts at 3. So if you add 4 to it, you get 7. Does that make sense? And so in the same way, we're going from negative 4 to 4, and we're adding all these areas up to the original value, basically, and you end up with 5.
So it's more accurate to use the one they have?
What do you mean the one they have?
Like, you know how we're using negative 4 every time?
Oh, no, actually, I wanted to talk about that. It's better to use just the one that you left off on because it's faster.
Okay, that's fine.
But you should get the same answer. So this, bring that back. Okay. So for the last one, now I want to show you guys a faster way to do this. Okay. Well, I hope it makes sense, but yeah, you don't show shortcuts first because shortcuts make sense because of the long way you did already. So here's the shortcut. Guys, don't you agree that if I'm going to find the integral then from -4 to 6 now, that's the same thing as this. I'm just going to go up to 6 now instead, right? So all you have to do is take your last answer and add the new area on it. Good. Yeah, that's faster. That's the way to do it. So what is this little area right here? 2. So if I add 2 to this, I get... Okay, so this is about, like, what, 2-ish? And this is going to be about 7 minus 3 is about 4-ish. So what would you guys say is the absolute max?
7.
And min?
5 minus pi.
5 minus pi. I want to say the actual answer there, 5 minus pi. But yeah, 2 is approximately what it would be. So this is our min right here. And that's that. What time is it? You guys want to do one on your own?
No, I think it's time to leave.
Well, if you want to, here it is. If you feel confident, you don't want to practice, you don't have to. I'll put the answer up in a minute. Okay.
Cause like I could have come to work for work, even if credit.
It's the one with the dude who's like illustrated. It's like a diagram.
I'm an alternative.
What do you think, Austin? Did I do it? Okay.
That's all.
Huh?
Did
You okay?
Good, okay.
No, we're not agreeing.
Mr. Rose, do I have to turn in the AP transform? The AP transform? Or what's that do?
Tomorrow.
Yeah, I need the AP. Do you have any
Now
extra
I'm going to
copies?
eat tonight. So I might not be able to get back to your questions tonight.
Or
You
could
just send them and I'll get to them later, or just
it'll be like 3 to 5.
I'm sorry.
Chapter, like different lessons.
Go to class, go, we gotta go.
I'm
planning on doing a lot.
Do I have different lessons?
I'm
Is that what you said?
Some of them are kind of similar, like 2 to 5.
Huh. No, all I have is what's there on the Google Class.
Alright, now you walk through.
Well, yeah, I'm just gonna. Is it okay if I ask you to like do an example?
Oh yeah, yeah. Just I see what you're saying.
That's
Yeah,
what I was
Hey, hold up,
saying.
hold up.
Yeah,
I'm just getting a green copy.
Thank you.
You have an extra copy of that?
Of what?
The green thing?
Yes. Thank you.
I'm like Catholic.
Alright, I'm getting it.
You never got one?
No, not me. I'm Catholic.
You didn't get one yet?
Yeah. What's wrong with you?
The printer is not working. Low
Every computer left.
Sorry, kiddo.
Oh, try to make me feel.
Is your printer not working too?
It's my printer works. It's not linked to my computer, and I've tried for like 30 minutes to do it myself. And the tech guy's got so many problems on my computer already. I'm not even bothered.